Okay, like I was saying, we're going to talk about tangents today, but tangent, now we've talked about tangent before. Somebody even asked that. They said, oh, haven't we done tangents already? Yeah, but we did what? The tangent of an angle is equal to, that's supposed to be a theta right there, is equal to the opposite over the adjacent. Agreed? Is that the tangent we're talking about today with circles? No, it's not the tangent we're talking about. I don't even know if there is a relationship between that word and what we're doing today. I mean, I kind of doubt it, but I mean, they use the same exact word, spelled the same, sounds the same. I'm not really sure the origin of the word tangent. You can look it up if you want. I'm not going to. Okay, so let's just talk about what a tangent is with the stuff we're doing today. So let's draw a circle and describe what a tangent is. A tangent is a line that only hits the circle at one point. Remember, the circle itself is the line that goes around it. It's not in here. All right, so a tangent is a line that touches or intersects, probably is a better geometry word, that intersects the circle at only one point. So what's that going to look like? Is that going to be it right there? You say, oh, it only hits it at one point. But remember, it has to be a line, so that line would keep going. If that line kept going, it's going to hit the circle how? Right, it's going to go through the circle? Like, well, I'm just trying to figure out what you're telling me. There you go. Oh, that's good. She said it's going to look like this. She made a circle like that, and a finger like that, and that's exactly what it's going to look like. All right, so let's try to draw one. So, is that a tangent right there? No, because it's not going to hit the circle. Is that a tangent? No, because it hits the circle how? Uh, no, it's not going to be one of those because it can't. Oh, that's what that looks like, right? But it's going to do what? Tell me when. About right there, exactly. Okay. Yeah, it looks like a big point, but our point's really big. No, points don't have any width, they don't have any depth, any height, or anything. But when we draw them, yeah, it definitely looks like it hits more than one point, doesn't it? Wow, that was squiggly looking line. So it looks like there's a point here, 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 all along, doesn't it? But it all depends. I mean, that's just us drawing it and representing it. So our representation of it, let me draw like this. Okay, that right there would be the point. Okay, it only hits at one point, even though it looks like it hits at a lot of different points. Okay, it only hits at that exact one point right there. It doesn't go through it. If it hit it more than one point, it would actually go through the circle, wouldn't it? And that's a different word. We're going to talk about that word probably tomorrow. All right, but this word right here is tangent. And so a line that is tangent just hits at one point. See how it kind of like, remember I said the phrase, like if you're in conversation, then you start going down some way that you weren't originally going. So this is the original conversation right there. You're supposed to be on track, right? What does a tangent do? The tangent of my conversation goes in this direction, way off from where I was supposed to go. Does that make sense? So that's an expression people use all the time. Probably not young people use it very often, but old people have said that. And if you listen to their conversations, like, oh, there he goes again, off on a tangent, well, then you know exactly what they're talking about. This represents a tangent. Okay? Everybody with me? All right. Now, we call this point right here. That point is pretty important. Yeah, exactly. It's the point. Well, let me do this nice. Okay, the point of tangency. 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 My writing's horrible today, but not that it's much worse than normal. All right, there you go. So that's a point of tangency. So the line itself is the tangent. Okay, it's the tangent line, if you want to call it that. The point right here is called the point of tangency. How many tangents can you draw to one particular circle? I don't know. 4? So there's only 4 tangents to this circle? There's only 4 different places that I can have a line just hit? You're right. Yeah, exactly. As many as you want, which means it's infinite, right? Exactly. I've had people before say 360. Why would they say 360? Where'd they get that number from? Yeah, for one tangent per degree. But there's in between degrees, aren't they? aren't there? Yeah, so you could have an infinite number of tangents if you wanted to, and we're not going to try to draw them because that would take a while. It would actually take all of eternity to do that, and we still wouldn't be done, would we? Let's do this one. Let's do a circle here, and then another circle. Yeah, it would. Yeah, but it's, technically it would go infinitely. It doesn't matter how big or small the circle is, it would go infinitely. Yep, so you keep drawing it until never. Right, exactly. So let's do this. I'm going to put these two circles, watch. Yep, boom, right there. How many points do you think these two circles meet? I try to draw it that way. At one point. They intersect at 1 point. So I could actually draw a tangent to both of these circles at the same time. I could draw one tangent to both of these circles. Oops. Scooch it over a little bit. I'd say about right there. Does that look about right? So there's a line here, got two circles, and look where it hits. It hits right there at that 1 point, the point of tangency, and so I would call that a common tangent. Common. Because it's tangent to both of the circles at the same time at the point of tangency. There's other ways we could draw common tangents. Yeah, we'll call that a common tangent. Yes?
Was there something that's like called when you have like one circle and then the line goes diagonal, but then like through the line there's another circle and it hits, and this is the same line? But
Like this, but it hits both of them?
yeah,
There is, and we're going to be doing that in just a second. Yep, absolutely right, there is. And we will take a look at that in just a little bit. I'm looking at the example they give for this common tangent, and it seems like they're skipping one. And I'm wondering if the one that you said, Brooke, I think you can still consider that a common tangent, because if it's tangent to both of the circles, if it's one tangent that's common to both of the circles, then yeah, it'd be a common tangent. Let's do this. Let's grab this one and this one, and let's see how else. This is what Brooke was saying. And I might have to do some adjustments on this a little bit. I might have to maybe kind of go like this, maybe scooch it down. That's pretty close. See that? So watch. It's tangent to that circle, and it's tangent to this circle, so it's also tangent to both circles, isn't it? So I could consider that a common tangent, couldn't I? All right, because it's tangent to both of these circles. In fact, do these circles really have to be touching each other like this? Not necessarily. Okay, they could. This circle could be like right here. And it's still tangent to both of those circles, isn't it? Okay, so I think you could call that a common tangent as well. Where's there another common tangent? This is what they do. Again, I might have to, yeah, like this. I might have to mess with it a little bit. Maybe a little bit more. That's pretty close. Good enough. Okay, so watch. If it's tangent here, that would be a common tangent as well. You get the idea? Okay. All right, so that's common tangents. Not that big of a deal. Oh yeah, they do have an example. If you look on page 718, look at page, yeah, look at letter B. So if you have two circles that are separated like this, and the circles are not tangent to each other, then you can actually have, how many tangents could you have?
4.
You can actually have 4. You can have 2 going through like this, then 2 on the outside, 1 here and 1 here. I'm not going to draw all those for you, but they draw it in the book. So you could have 4 of them, couldn't you? 4 common tangents to 2 circles like this. All right, enough of that. Let's do this. Let's draw another circle here. And this one right here we're actually going to use to solve some stuff. Let's find the center of the circle. Be right there. Put a little dot. Okay. It says, in a plane, a line is tangent to a circle if and only if it's perpendicular to the radius drawn to the point of tangency. What? Well, let's do this. Let's draw it. Let's draw a radius to here. I could draw a radius anywhere on this circle. I just chose to make it just go straight down like this, just because it makes my tangent lines a little bit easier. Now, that's not tangent right there, is it? So what am I going to have to do? Scooch it up until it hits, boom, about right there. Okay, it hits right there. And this is a tangent. Only hits a circle at one point. Now, if it's tangent to the radius, see how the radius came to this part right here? If this tangent is, if they share the same point of tangency, that's not a good way to say it. How do they say it? They say if it's tangent to a circle, if it's perpendicular to a radius drawn to the point of tangency. So if I have a radius, and it comes to this point right here, and this tangent is tangent to the circle where the radius hits the circle. Do you see it? So the radius comes out, hits the circle right here. My tangent line hits that same exact point. My point of tangency is that same exact point. What do you think might be true about the angle that's formed between those? They are what? They're perpendicular, right. Now I'm going to see if I can do this. I don't know if I can do this or not. I kind of doubt it. Boom. Ah, no, didn't work. I want it to anchor right there at the center and scooch this thing around. Wonder if I did it like right here. No. Yeah, I wish I could make it do this. I know I could make this thing anchor right there. Touch that. Yeah, I can do that. Let me try this one more time. Sorry. I'm just practicing with you watching. So, what if I do that? I'll click there, and then I'll do this. Ah, that's what I wanted. Perfect. Look at that. I knew I could do it. See? See, look at that. Isn't that cool? So it doesn't matter where that radius goes, does it? Okay. Well, I discovered something new that I could do. I thought I could do it, but isn't that cool? So look, what am I trying to show, though? I'm trying to show it doesn't matter that the radius goes exactly straight down. It doesn't have to be perpendicular, or it doesn't have to be vertical, does it? Okay, as long as the tangent hits where that radius is, then it's going to be perpendicular. That angle has not changed at all, has it? It's still a right angle. We'll just take it back to there. So this will be perpendicular, and that can be very, very helpful, okay, when you're going to solve some problems. In fact, let's do an example. Is that all right? That was a theorem. It's theorem 1010. I don't care what the number is, but that is a theorem. They don't give it any special words or anything, like a name. They just call it theorem 1010. And that would be true. Now, what if I said this? What if I said I had a line that was already perpendicular to a radius? What could I say about that line then? Yeah, I don't know. How would I say that? It says a line is tangent to a circle if and only if it's perpendicular to a radius drawn to the point of tangency. Okay, it's perpendicular if it's drawn to the point of tangency. Or I could say if it's drawn to the point of tangency, then it's perpendicular, right? It could go both ways. Well, anyway, enough of that. Let's just do an example. Let's see if this makes any sense. So here's a circle. And this is the kind of stuff that they're going to ask you to do. And they drew the radius, oops, to about right there. And then they drew this about like that. And then they connected this one to this one. All right. And they say that JL is a radius of angle J. This is J, and this is L. So they said that's a radius. It says determine whether KL is tangent, KL, that would be K. Determine whether it's perpendicular to this. Well, they put some numbers in here. They say this is 6, this is 15, and this is 9. Now the 9 is, what's the 9? Is it KJ? What do you think that 9 is? It's just from K to where? To the circle, right. That's the 9 right there. So don't get confused on this, because some people think the whole thing is 9. But it doesn't make sense that that would be 9, does it? Because look, I want to show that this radius is, how should I say it? Determine whether KL is tangent to circle J. Determine whether KL is a tangent or not. How do I know if it's a tangent? Well, if this was a right angle, then this would be tangent. But how do I know that's a right angle or not? What do I do? How do I know that that's a right angle? We did this before. We had a test to see if it was a right triangle or not. Do you remember that? By the way, what is it from the circle to this thing right here? It's 6, isn't it? Okay. Did I do this right? You know what? That's not 6. I knew this wasn't going to work with 6 being right there. I just didn't. I just read it wrong. That's 8. Because I was like, wait a minute, this is not going to be a right triangle if that's 6. So that's going to be 8 right there. Now it works. Okay, now watch this. How do I know if this is a right triangle? Now, I cannot say that that's a right angle right there yet. Okay, I got to figure out if that's a right triangle, and then if it is, then that's a right angle. Dominique. This one right here?
Yeah, the common point.
Yeah.
Since the radius, the line from the radius to, well, the line of the radius.
Give me letters. JL?
Yeah.
Okay.
And a tangent line intersect.
Right.
Makes them perpendicular. Right?
Well, that's what we're trying to show. We're trying to show if they really do make this perpendicular. They don't tell us it's perpendicular, and they don't tell us that KL is a tangent. They just give us these numbers. So how do I know if KL's a tangent or not? Okay, well that just tells if it's a triangle or not. How do you tell if it's a right triangle or not? Yeah, do Pythagorean theorem. That's right. It's basically Pythagorean theorem. If this works with Pythagorean theorem, then this is a right triangle. Make sense? So what's this whole side right here? 17. Now this is actually one of our special triangles. Do you remember this triangle? Remember we did those what do they call these triples? Pythagorean triples. This was actually one of our Pythagorean triples. It was 8, 15, 17. Take my word for it. So I've got an 8, I've got a 15, got a 17. Well, then you'd have to do Pythagorean theorem and see if it works. And right, if it doesn't come out, so you have to do this: 8 squared plus 15 squared. That has to equal 17 squared. If that's true, do it. It does work. Okay, it's 289. That's 289, and that's 289. No, I just know 17 squared is 289. And I know it's equal to this because I knew that 8, 15, 17 was a special triangle. Okay, so I do know that it's a right triangle. That means that this has to be the right angle. How do I know that's the right angle and not this one?
Because we're looking for the point of.
Yeah, but not just because of that. But if I just had a regular old right triangle, how do I know that that's my right angle? Jesselyn. Right. Okay. Yeah, it's opposite the longest side, right? So if it's a right triangle, the right angle has to be opposite the longest side. So that has to be the right angle right there. Now, what do? We determined that that was the right angle. So what must be true about KL then? It's got to be tangent to the circle. Okay. So that was a lot to do, or a lot to think about to figure out that that was tangent to the circle. But you had to show that that was a right angle first, and the only way we could show it was to show that that was a right triangle. Got it? Okay. Oh, sorry. Sometimes I just get lazy. Let's do another one. Dominique, what color would you like me to use? Light green, right there. Okay. You don't like that green? All right, let's do another one. Another example. Well, we haven't seen it yet. See, there it is. Isn't that beautiful? It looks a little more green. On the computer, it looks a little bit better. Making you woozy? Is it really that bad?
Yeah.
You wanted
It's really that bad.
this? How about that one? Is that better?
Yeah.
Barely any different. All right. Okay, that's fine. That's fine. That's fine. Not gonna argue anymore. All right, here we go. And they tell you that this is X, and this little bit right here is 8, and this bit down here is 12. And the question says, now this time they word the question a little differently. They say that JH is tangent to circle G. JH, let's put some letters in here. That's J, and that's H, and this is G. All right, so they tell you that JH is a tangent to this circle. So that tells you automatically what kind of angle do you have here. You know that that's a right angle. Do you see the difference before? Before they were trying to get you to figure out if it was tangent, and so we had to figure out if that was a right angle or not. This time they tell you, yeah, this is tangent. So if it's tangent, we know that has to be a right angle. That means that's a right triangle, and now you got to solve for x. So what would you do to solve for x here? Pythagorean theorem, right? Would you go x squared plus 12 squared equals 8 squared? No. What is this? G to the circle. This is also an x, isn't it? Okay, so now our math is just a little bit more complicated, but let's see if we can do this. It's going to be x squared, which is this one, right, plus what? 12 squared, which is this one, and that equals the hypotenuse squared. What's the hypotenuse? Is it 8x? It's 8 plus x, or I'm going to put x plus 8. It's going to be x plus 8. That's the whole hypotenuse, right? And what do we have to do with that? In parentheses, good, and squared. Don't put x squared plus 8 squared. It's not the same thing. All right? So let's do the math now. I'm not even going to mess with this just yet. I mean, you can put 144. Is that all right? We can do that. Now, what's this? It's the same as, good, times x plus 8. Very good. When you square something, you multiply it by itself, right? That's what you do. You cannot go x squared plus 8 squared. Don't ever do that in Algebra 2 next year, all right? Because whoever's teaching you Algebra 2 will think I taught you nothing, all right? Well, at least your Algebra 1 teacher taught you nothing. But right now, you can't just go 8 squared plus, or x squared plus 8 squared. You have to multiply it out. It's FOIL method. So what do you get? You get x squared plus 8x, which is plus 16x, plus 8 times 8, which is 64. That's exactly FOIL method. Okay.
Explaining FOIL methods in my class at least 2 or 4 times a week.
Yeah. Hate FOIL, that's nice. It's just distributive property is all it is. So look what happens. I want to solve for x. So what can I do? Oh, I can get rid of x squared, can't I? Subtract x squared from both sides. I got subtract 64 and blah blah blah. You do all that and you get 5. I won't bore you with all the math. All right? So x equals 5. That's it. And that's our radius to that circle, isn't it? All right? Good. Let's do another. You don't even know why I say do another like that, do you? You want me to tell you why?
I know.
Do you want me to tell you why?
No.
There's a reason. There's actually a reason that I said it like
You
that.
really don't have to.
I will go off on a tangent. Yes, this is a tangent today. So we don't do bunny trails today. We do tangents today. Oops, wait a minute. Oh, thank you. Thanks, Morgan. Back in the day when the Sixers, who's a Sixers fan, the announcer to the Sixers at the stadium, at the, it was the Spectrum back then. His name was Zinkoff, Dave Zinkoff, I think his first name was. And very, very popular, and he'd announce the players, and he says, Julius Erving, and he was really, really popular the way he would talk. And then when somebody would get up and they would shoot a foul shot, then you'd have another shot, right? And he'd say, and he gets another, like that, with the, instead of saying the R. And so that was really popular. People used to say that. And a friend of mine, anybody go to Elkton Christian before? Did you know Mr. Wilson? Yeah. Okay, he announced our basketball games because I taught with him at Newcastle. And he announced our basketball games. And every time somebody would get up and take another shot, like a second foul shot, he'd say, and he gets another, like that. So anyway, so now when I say we're going to do another one, so I say, so now why do I keep doing that? I want a line. All right. A worksheet? No, why does everybody keep saying that? No, it's from the book. Oh, she said it twice? No. We are now. Watch. These are tangent, but look what I'm doing. I'm only going to draw it to the actual point of tangency. Okay. So
Looks like ice cream.
It's a really big beak.
looks.
Yes,
There's
it
a
does.
bird.
Okay, what does it look like
There's
now?
his eye.
Ice cream
There's his
is
circle.
not
Yeah.
No, that doesn't work. Okay, here we go. Is drawn to the point of tangency. So both of these lines right here are tangents. Now watch. If I had a point out here, I just picked any point out here, and I drew a line tangent to the circle this way, and I drew a line tangent to the circle this way, what does it look like might be true about both of those?
AB equals BC.
That's right. So now technically a tangent is a line, but if I stop that line at the point of tangency, I have a line segment, don't I? And that's exactly what I've done. So I could now say that AB equals CB, or BA equals BC. Doesn't matter how you do it. So that would equal that. And that really comes in handy sometimes, understanding that. So if you have a point outside the circle and you've drawn a tangent to the you've drawn two tangents to that circle. Could I draw any more? Could I draw 3 tangents to a circle from a point outside the circle? Could I draw 3 tangents? Is there another tangent that I could draw from this point B? No, there's not. Okay, because if I drew it this way, it would never touch the circle. If I drew it this way, it would do what? It would go through the circle and hit it at 2 points, and it wouldn't be tangent, would it? It would be something else that we're going to talk about tomorrow, but it wouldn't be tangent. Okay, so these 2 tangents would be equal to each other, and that's kind of nice, isn't it? So here's a quick little example, and we will be finished. How about that? I told you the circle stuff was easy, didn't I? Circle's been pretty nice and easy, I think. So let's do this. Let's take a point. Oops. What happened there? Let's take a point outside the circle. Let's just put it right here. And let's draw 2 tangents to the circle. But let's not go like all the way through. Let's just stop at that point of tangency. Is that all right? Yes. And then here's a tangent. Yeah, I mean, we had point of tangency, right? So that was... No, we call it point of tangency. It's the actual word. So look, what would that be? That would be like an adjective or adverb or something. Tangency, what would that be? The point of tangency, though? That's a noun?
Yeah.
The point would be...
It's an object of a preposition.
So, oh, it's object of preposition, so it would be a noun? Okay, there you go.
Anyway.
Yeah, because it's of. It's of what? It's of tangency. But don't adverbs like end in a Y or something like that?
L-Y.
L-Y. Oh,
Not all of
L-Y. Not all of them? Okay, I don't know. All right.
Why are we doing
So watch. Actually, let's do this. Well, because you should always want to learn. It doesn't matter if it's in your field or not. You should always want to learn about everything.
So you're asking your students about it.
Hey, if you know about it and I don't, then I'll ask you. I'm not, I'm not so, what would the word be? I'm not so, just like uppity. Not, you know what I mean?
Uppity.
Like, not uppity. It's not what I'm looking for.
Uppity.
It's, I don't want to, well, that's what I'm trying to think of a good big word. Yeah, I don't want to feel like superior to you. I mean, if you know something that I don't know, then I want to know it, right? Okay, anyway. So here's our situation. This is the only thing that they tell you, but they do tell you, they do tell you that the 2 things are tangent to the circle. So they call this circle D. They call this, that right there is a B. This is C. That's exactly right. Okay, so they tell you that AB and BC are tangent to circle D. They have to tell you that. You can't just assume it, okay? They tell you that. So if they're both tangent and they meet at a common point right here, what's true about the lengths of those? They are equal to each other. Set them equal, solve for x. You can do the rest. Got it? All right. I think we covered everything. We even did examples for both of those theorems and everything. Why am I getting up? Here's my book right here. We are having a quiz tomorrow.
We are?
Yeah, we are. I think I told you that last week, that we were going to have a quiz early in the week. I bet you I did. Oh, what am I writing tangent for? Because that's in my book. Section 10.5, pages. That's what you want, right? Pages 722, 723. Yeah, the quiz is on 1 to 4.
Tomorrow?
Yep. 13 to 27. There it is. So 13 to 27, and you have a quiz tomorrow, and that covers 10-1 to 10-4. There are 10 questions. There are 10 questions, so it's a 20-point quiz, okay? So 20 points, 10 questions. That's supposed to be a 4. All right? Everybody got that? Okay.